Okay, so the derivative of linear and constant functions. So basically, we just explained before that the derivative is the gradient of the tangent. So if we were to have some linear function, so linear being a straight line, then the tangent of this function, and I'm going to use a different color, I'm going to use red, the tangent of this function, so basically if I pick some random point and draw a line that goes through that one specific point and makes a tangent, well, it's just the line itself. Okay, and we decided in our last video that the gradient, that the derivative f dash of x is equal to the gradient of the tangent. Okay, so in this case, we've got some function, okay, and the tangent of that function, that linear function, is the function itself. So the derivative, which is the gradient of the tangent, is just the gradient of the function. So if we had some function, okay, which is equal to mx plus c, so the linear function, so is a linear function, okay, then the derivative itself, okay, so then the derivative, okay, is equal to m and is a constant function, okay, because the derivative, it doesn't matter which point I pick on this graph, okay, the gradient of the tangent, okay, or the tangents that I draw are always going to be the same, and the gradient of that tangent is always going to be the same as well. So the derivative at any point on the linear function is just the gradient, okay? So for example, if we have y is equal to, well, sorry, I should write this as in function notation. If I have f of x is equal to 3x plus 2, then the derivative f dash of x is just equal to 3, because the gradient is 3 of that graph, and it's the tangents that we're going to draw are all going to have gradient 3. Okay, now let's say we have a constant function, okay, so something that looks like this, okay, so this is our function here, okay, and I'm going to draw my tangent along that function, and it looks like that, okay. Oh, look, that's nice and easy. What's the gradient of that function? Okay, well, the gradient of that function, so f of x, let's say it's f of x is equal to some constant value. Okay, then the derivative of that, well, you can see, what's the derivative of our horizontal line? It's just 0. Okay, so the derivative of a constant function is just 0, because it's a horizontal line. A horizontal line has a gradient of 0. So let's have a look at applying some of these in an example. So the first one is write down the derivative f dash of x of each linear function. Okay, so we're going to apply what we just learnt to some functions that we have here. Okay, so 4x minus 2. So we say, well, what's the gradient of this function here? Okay, so it's a linear function. So the tangents of this gradient are just the gradient of the function. So f dash of x is just equal to 4. Okay, so if I was to draw that, it would have a function value, it would have a gradient of 4, and if I was to draw tangents, which is just the same as the line, it's the same gradient there. Okay, part B, we've got f of x is equal to 7 minus 3x on 2. So what we're going to do is I'm going to rewrite this as 7 on 2 minus 3 on 2x. Okay, so again, it's just a linear function, so the derivative f dash of x is just negative 3 on 2. Okay, just like that. And our last one, C, is a constant function where f of x is equal to negative 5. So the value of my derivative, okay, at any point, so remembering if I was to draw a picture of this, okay, here's minus 5 down here. This function looks like this. Okay, the gradient of that function, well, that's just 0. Now, these results are really important. It's going to make us it's going to help us differentiate some of these functions a lot easier come later on. Okay, so it's a good thing to remember these ones, so that the linear function is just the gradient of that function, and then a constant function is just 0. But later on, when we use some other techniques to do bigger powers and bigger functions, we will be able to do those without actually having to remember these results specifically. So with that being said, that's the gradient of a linear function, okay? And in the next video, we'll have a look at the derivative of a semicircle.